This is an introduction to the measuring point perspective drawing technique. So we're going to use a technique called measuring point to generate cubes that are in 30-60 perspective and 45-degree perspective. I will now do a demonstration of how to use the two techniques. Please refer to the week 5 measuring point perspective exercise sheet, which has the step-by-step instructions. That'll help you move through the exercise. So to generate a really accurate cube in perspective, we can use the measuring point perspective technique. We use some of the tools that we've been learning about for the last few weeks. So we need to add a horizon line. We need to add in a couple of vanishing points. And then we can use some techniques, mechanical techniques, to draw a really accurate cube in perspective. So I'll draw in the horizon line first up. I recommend that you draw it around about 1/3 or 1/4 of the way down the page. And we'll just label this the horizon line. The other thing we need to do is add in some vanishing points. So I'm going to add in a vanishing point on the right-hand side, just there. And another vanishing point on the left-hand side, just there. Now, if you have a compass, what we want to do is accurately bisect the distance between the vanishing point left and the vanishing point right. If you have a ruler, you could do it that way. You could also make a compass using a piece of paper and do it that way too. Essentially, what you want to do is, for example, locate the point of the compass at the vanishing point on, say, the right-hand side, and then you'll swing an arc like so. If you do the same thing from the left-hand side, what you're trying to do is establish where the halfway point is between the two vanishing points. And we'll just label that the halfway point. The next thing you want to do is get the compass again and put the pointy bit at the halfway point you just located, and then swing an arc, and then swing another arc with the pointy end of the compass at the left-hand vanishing point, and then locate where the 1/4 mark is. And we'll label that 1/4. Then do that again because we want to find out where the 1/8 mark is towards the left-hand side. So pointy end of the compass at the 1/4 mark, swing an arc, and then pointy end of the compass in the vanishing point left, swing an arc, and then locate where the 1/8 point is towards the left-hand side. From there, we want to start drawing our cube. So we want to locate where our baseline or measuring line of the cube is going to be. I suggest you draw this about 1/4 of the way up from the bottom of the page. So I'm going to draw in a line which is going to run across the page just here. And this is where we're going to draw the bottom corner of our cube. I'm going to switch colors to make it a bit easier to follow. From the 1/4 line, I'm going to draw a vertical line straight down until it crosses the baseline. And now I can start to draw in my cube. And the front corner of my cube, front bottom corner of my cube is going to be where that circle is I've just drawn on the baseline. I draw a line back to the vanishing point right, a line back to the vanishing point left, and then this gives me the bottom edges of my cube. Now we need to accurately work out how to determine where the back of the cube is. So far we've been doing it through intuition. This technique allows us to accurately work out where the bottom of the cube is. Now to do that, we need to establish how tall our cube is. I recommend you make your cube somewhere between 40 and 50 millimeters tall on the front edge. So if I, in green, now I'm going to draw this line in, which is going to be the front edge of my cube. And I'm going to draw another line across. It's going to be the top corner of my cube. Now, with my compass, again, I'm going to put the pointy end down here at the bottom corner of my cube and set the radius to the top corner of the cube, and then swing an arc, and then also swing an arc to the right and left hand sides, and then just mark in where that arc crosses the baseline. From here, I'm going to draw in a line which goes from where the left hand intersection of that arc was to the halfway point that I determined on the horizon line earlier. Now this halfway point becomes our measuring point. I'm not going to go into how this works, you just need to know it works. And this is going to be the measuring point left, which is kind of counterintuitive because it's on the right hand side of where our cube is going to be. Now where that line crosses the bottom edge of my cube that I drew in earlier, that is where the back of the cube is. So I'm going to draw in a vertical line, and then from the top corner of my cube, another line back to the vanishing point. And now I have the left-hand face of my cube. Now, if I do a similar thing on the right-hand side, so I'm going to draw a line from where the arc crossed the baseline, and I'm going to draw a straight line back to the 1/8 line. Now where that crosses the bottom edge of my cube is where the right hand edge is of my cube. So I'm going to draw a vertical line, and then from the top corner, a line back to the vanishing point on the right hand side, and fill that information in. So the 1/8 point becomes a measuring point for the right hand side, even though it's on the left hand side of the cube. Now I can complete my cube by drawing lines back from the two top edges to the vanishing points, and I end up with a really accurately drawn cube in what's called 30-60 perspective. Now 30-60 means if we were the viewer standing here and we're looking this way in elevation view, it means that the cube essentially is positioned like so in front of us, and if we were to take an angular measurement in elevation, that would be 30 degrees and that would be 60 degrees. So this is what we would call a 30-60 cube, and this has been completed using the measuring point technique. So the next thing we wanted to do is draw a cube in what's called a 45-degree perspective using the measuring point technique again. So just like with the 30-60, we'll start by adding in a horizon line first up, and I recommend you draw that about 1/4 of the way down the page. We'll locate our vanishing points, so our vanishing point on the right and our vanishing point on the left. Then, using a similar technique to last time with the 30-60 cube, you could use your compass to bisect the distance between the two vanishing points. So I would put the pointy end of my compass at the vanishing point right, and then swing an arc that's over the halfway distance. Leave the radius the same and swing an arc from the left, and then draw a line upwards, which will then give you the halfway point between the two vanishing points. Now this time we want to use the compass again to determine the 1/4 mark on the left and the 1/4 mark of the right of the halfway point. So I set my compass again to be visually over the halfway point between the vanishing point left and the halfway point, swing an arc, keep my radius the same, put the pointy of the compass on the left and swing an arc, and then draw a vertical line upwards, which will give me the 1/4 mark. Do the same thing on the right hand side. So swing an arc with the pointy end at the halfway point, pointy end then at the right hand vanishing point, and then determine where the 1/4 mark is on the right hand side. Now to complete our cube in the 45-degree measuring point perspective, we start by drawing a vertical line from the halfway point. Draw it straight down, and then we need to then determine where our baseline is going to be, just like we did with the 30-60 technique. I recommend you draw the baseline to be at least 1/4 of the way up the page. And this will be our baseline. Now from here, the intersection of the halfway vertical line and the baseline is where the bottom corner of our cube is going to be. So then we can send that back to the vanishing point and that back to the vanishing point. And this gives us the bottom edges of our cube. Now we're going to use the measuring point technique again to determine where the back edges of the cube are. So to do that, we need to determine the height of our cube. And I recommend you make this at least 40 to 50 millimeters tall. So the green line I'm drawing in, and this is going to be the height of my cube. So the top corner of the cube. Then I would get my compass, put the pointy end at the bottom corner of the cube, set the radius to be the distance between the bottom corner and the top edge of the cube, and then swing an arc, and then swing an arc on the left hand side as well. And where that crosses the baseline, we can use these points now to start to determine where the back edge of the cube is. So to determine where the back edge of the cube is on the left hand side, draw a straight line from the point on the left hand side that we just found with the radius back to the 1/4 mark on the right hand side on the horizon line. So this point becomes our measuring point on the right hand side, but it's the measuring point left. So using it for measuring things on the left hand side of the cube. Now where that line crosses the bottom edge of our cube, draw a vertical line. Now we know where the back edge of the cube is. We can draw a straight line from the top corner of our cube back to the vanishing point. And we now have the left-hand face of our cube. Do the same thing on the right-hand side. So the radius that we drew, where it crosses the baseline, draw a straight line back to the 1/4 mark on the left-hand side to the horizon line. This 1/4 mark becomes our measuring point on the right-hand side of our cube. Where that crosses, draw a vertical line up. And now we can complete the right-hand side of our cube by drawing a straight line back to the vanishing point right, and then completing that face. Now, if we're doing this correctly and we're looking at the cube in 45-degree perspective, the two back edges should line up, or at least be within 1 millimeter or 2 of lining up if you draw a vertical line across there. If they don't, you've messed up your construction, and I suggest you kind of have another go at it. Now we've got the two faces, the left and right hand face of the cube. We can complete the top face now by drawing a lines back to the vanishing points on the left and the right hand side, and establishing where the top face is. And again, if you've drawn this correctly, the back edge of your cube should be on that halfway line vertically. Because if we look at this view in elevation, so if you're the viewer, you're here looking this way, what we're looking at in this situation is we're looking at a cube that is 45 degrees from our direct line of sight. and we should be able to see an equal amount of both faces. So 45 degrees and 45 degrees in elevation view. This is what we're looking at, which means we should be able to see the back edge of the cube in line with the front edge, because that's how we're looking at this cube. So this has been the 45-degree cube using measuring point perspective technique. For part 4 of today's exercise, we've given you some elevation drawings, and if you refer to part 4, you'll see you have 12 shapes there that give you a front, top, and right-hand elevation view of the particular cube-based object that you need to draw. So what we're looking at doing is turning those elevation views into a perspective drawing. So I've given you some models on the Learn Online page, which you can then open up in a piece of software called eDrawings, which is available for free on your PC or Mac, or you can put it also onto your iPhone or Android device. And if we look at the first cube that I've given you to use in eDrawings, this will help us understand the type of views we're looking at when we refer to orthographic projection. So when we're looking at the bottom left-hand view in each elevation, we're looking at the front of our cube. The view above is the top. So you need to imagine that you're rotating the object around, just like I did here, and then looking at the top. And then we can take that back to the front. And then the view on the right-hand side of the front view is the right-hand elevation view, just like so. So this is what we refer to as an orthographic projection in third angle projection. So we look at the front, we look at the top, and then we look at the right. The eDrawings app has a pretty cool function where it will do this for you if you hit the play button. So it'll go from 3/4 view to front to the right, and then to the back, and we'll continue to animate around the object. And I've given you some examples of the cube-based shapes that you need to draw. So we've got shape number 1, which is this one, these eDrawings will help you understand how to draw the object. So if you look at the elevation view for object number 1, it looks like this, and this is us looking at the front view. The view above the front view is what we're looking at now. And so if we rotate that back down to the front view, and then the view to the right-hand side of the front view is this elevation. So your task is to try and turn those 3 views for each shape into a drawing which looks something like this. Now this is not in perspective. Your drawing will be in perspective, and you'll use the measuring point cube that you completed in part 1 and 2 as a framework to draw these shapes. And we want to use some of those division of perspective techniques that you've been learning about last week to help you accurately divide up that cube. Refer to the examples in part 3A of this week's exercise sheet as well, which shows you how to add elevation views below the cube that you draw in perspective, and then how to use the measuring point to then accurately complete the cube-based shape in perspective.